You see here, amine is here. We are treating with the excess of methyl iodide. And then we are treating the silver oxide. Third step here, these combination, you should recognize as Hoffman elimination here. So amine get methylated, just like we talked about. Amine nitrogens attack the methyl iodide. It's going to make a tertiary amine, but we have an excess, so it's going to go again. Eventually, we got the quaternary ammonium groups, which has a iodide as a counter anion. The second step, silver oxide, will replace the iodide with hydroxide. Right? We install the base near the ammonium groups. Now, what it's going to do, it's going to pick up the proton, making elimination reactions. So, which hydrogen will be picked up by the hydroxide? These are the living groups. The word in which hydroxide is going to take them up. So, with a simple molecule, that's obvious. When it becomes like this, yeah, it's not that simple anymore, right? It gotta be adjacent carbon, right? So how many adjacent carbon this one has? It can be dark one's adjacent hydrogen, right? So dark one's also adjacent hydrogen there. So that can be picked up by the proton. This can be picked up by the proton, I mean the hydroxide. There's another one here. So we have 3 adjacent hydrogens. Can be picked up by the hydroxide and making eliminated reaction. So which one is going to go? Well, first, I want to tell you that this is a most substituted positions makes it difficult, right? So probably you don't want to go for that. I mean, if that one comes take this one up, this pair is going to be the liquid over here and put it out. This makes a side check product, but we fully know that side check product is not the product from the form by these reactions. So probably not this one. Let's think about hydroxide, get this proton, you're gonna make the double bonds here, and then kicking these things out as a neutral amine. That makes a less substituted double bond, right? So this is definitely more reasonable. That thing, I think if you do that will be the product we could form. Another one is, this can come, pick up the hydrogen on that side, and then you're gonna make a double bond here and eliminate that. So that's gonna make this. So all 3 hydrogen make a different products. This will be highly unlikable because that's a more substituted position. I think that will be the probably the good choice because we can least amount of substitutions. But I can also see that that can also happen too. I'm not so sure whether these two are kind of going together about the same amount. But the concept wise, you are forming the least substituted double bonds. So I think that makes sense to you, right? But I think that probably comes along pretty well too. But anyway, so that is the Hoffman elimination reaction we just talked about. The second reaction here is we have a tertiary amine, right? If it's not a tertiary amine, the co-elimination reactions are not possible. So you better methylate. That can be done by the same steps that we talked about. But you cannot go to all the way to the quaternary ammonium group because you've got to oxidize it, but it means the nitrogen that we want. You can only add the methyl groups up to third tertiary. Anyway, tertiary amine is right here. MCPDA is a peroxy acid. It can oxidize nitrogens, tertiary amine, to the amine oxide. When it becomes an amine oxide, you see here there's a base right there. That's the one that pick up the proton from the adjacent carbon. There are 2 adjacent carbon, more substituted side, less substituted side. Which one is likely the one that they picked up? We know the less substituted side. I mean, the more substituted side will make a side chain product, but that's not going to be the major problem. Whether it's going to pick up the less substituted side because it's a huge, big living groups, same reason, conformational reason. So these will be the major products that we can expect. Yeah.